Did you know your bones are actually stronger than steel? It sounds incredible, but it's true. Your skeleton is a masterpiece of natural engineering, far tougher than you might imagine. Let's dive into the amazing science behind why our bones are so incredibly resilient. First off, it's crucial to understand that bone isn't just a dry, static framework inside you. It's a living, dynamic material. Your bones are constantly being broken down and rebuilt in a process called remodeling. This allows them to adapt to the stresses you put on them, growing stronger where needed. They're lightweight, making up only about 15% of your total body weight, yet they possess a strength that rivals some of the toughest materials we can manufacture. It is this combination of being light yet incredibly strong that makes our skeletal system so efficient and remarkable. Think about it. Your bones support your entire body, protect your vital organs, and allow you to move, all while being light enough not to weigh you down. Now for the big reveal. Ounce for ounce, bone is stronger than steel. A block of bone with the same weight as a block of steel can withstand significantly more pressure without breaking. Imagine a cubic inch of bone. It can bear a load of at least 19,000 pounds, which is roughly the weight of 5 pickup trucks. This is why our bones can endure the immense forces generated by everyday activities like running and jumping, which can exert pressure several times our body weight on our skeletal structure. This incredible compressive strength prevents our bones from being crushed under the daily loads they carry. It's a level of performance that engineers strive to replicate in man-made materials, showing just how advanced nature's design truly is. So, what's the secret to this incredible strength? It all comes down to the unique composition and microscopic structure of bone. Bone is a composite material, much like reinforced concrete or carbon fiber. It is primarily made of 2 key components, a protein called collagen and a mineral called calcium phosphate. These 2 substances work together in perfect harmony, each contributing a different but essential property to the bone's overall performance. This clever combination is the key to creating a material that is both strong and resilient, a feat that is difficult to achieve in engineering. It's not just one thing that makes bone tough. It's the brilliant synergy between its parts. Let's break down these 2 components further. First, there's collagen. Collagen is a fibrous protein that forms a flexible, web-like matrix throughout the bone. You can think of it as the steel reinforcing bars, or rebar, in concrete. Collagen gives bone its elasticity and tensile strength, which is the ability to resist being pulled apart. Without collagen, our bones would be extremely brittle and would shatter easily, like a piece of chalk. It's this flexibility that allows our bones to bend slightly under pressure and absorb impacts without fracturing, which is vital for surviving falls or sudden shocks. This property is what keeps our skeleton from being fragile. On the other side of the equation, we have calcium phosphate. This mineral, in the form of hydroxyapatite crystals, deposits itself around the collagen framework. The calcium phosphate is what gives bone its incredible hardness and compressive strength, its ability to resist being squeezed or crushed. It's like the concrete that is poured around the rebar. This mineral component makes the bone stiff and rigid, allowing it to support our body weight and act as a solid lever for our muscles to pull against. So, while collagen provides the flexibility, calcium phosphate provides the rock-solid hardness, creating a perfectly balanced material. When you combine the flexible collagen network with the hard calcium phosphate crystals, you get a composite material that is far superior to either component on its own. The collagen fibers stop cracks from spreading, while the calcium phosphate provides the rigid structure. This is why bone is so tough and fracture resistant. It can absorb a tremendous amount of energy before it breaks. This principle of combining a soft, flexible material with a hard, brittle one is a common strategy in engineering to create high-performance materials. Nature, it seems, perfected this technique millions of years ago, right inside our own bodies. You might think that because bones like our femur are hollow in the middle, they would be weaker. But actually, the opposite is true. This hollow tubular design is another stroke of engineering genius. A hollow tube is stronger and more resistant to bending and twisting forces than a solid rod of the same weight. The structure distributes stress more evenly across the bone's surface, preventing any single point from taking too much strain. This design also makes our bones much lighter than if they were solid, saving a huge amount of energy when we move. The hollow space is also put to good use, housing the bone marrow where our blood cells are produced. The incredible design of our bones has not gone unnoticed by scientists and engineers. Researchers are constantly studying bone structure, from its composite nature to its self-healing capabilities, to draw inspiration for creating new and better materials. The field of biomimicry looks to nature's solutions to solve human problems, and bone is a prime example. By understanding how bone achieves its remarkable strength-to-weight ratio, we could develop stronger, lighter building materials, more durable and lightweight components for aircraft and cars, and even better medical implants that integrate seamlessly with the body. Nature is truly the ultimate engineer. So, the next time you think about your body, remember that you are walking around with a skeleton that is a true masterpiece of strength and efficiency. Your bones are a living, adaptable, and incredibly strong framework that outperforms many man-made materials. They are a testament to the power of natural design. Thanks for watching. If you found this fascinating, make sure to subscribe to our channel for more amazing secrets about the human body. See you next time.